Alright, here is a question on the same friction force on an incline. The question says an object of 400 kg, an object with a mass of 400 kg is on an incline that forms an angle of 35 degrees with the horizontal. The coefficient of friction is 0.45. That's the coefficient of friction of the surface. Then we are calculating about 6 questions. And the first question is asking us the component of the weight parallel to the surface. Component of the weight parallel to the surface. The other one is asking calculate the component of the weight perpendicular to the surface. Then the next question says calculate the friction force. The other question says calculate the force required to move the object downward at constant velocity. Then the other question says calculate the upward force required to move the object upwards at constant velocity. And then the last one says calculate the angle at which the object would move downward at constant velocity without any external force. Alright, so to answer the first question, what they're asking us for is the component of the weight parallel to the incline. So now remember what we said, component of the weight parallel to the incline is the sliding force. So your sliding force we said is the weight sine theta of the incline. But when we look at our question, the question does not have the weight. What it has is a mass. So we convert that mass to a weight by multiplying by 9,8. So what basically we are doing is the 400 times 9,8 to convert that mass to a weight. Then sine our angle theta, 35 degrees, and we get a weight, we get a force or a weight component parallel to the incline, and we work our calculator. Make sure your calculator is in degrees. When we punch sine theta, that theta should be in degrees. We get 2248,42 newtons. Okay, this is newtons. If they had required us to give our answer in kilonewtons, we'll divide by 1,000. We convert that to a kilonewtons. Alright, then the next question is for the weight component perpendicular, which is now the normal reaction. Perpendicular means normal reaction. Again, it is the weight cos theta. Always write your formula before you can substitute. Again, 400 times 9,8 cos our angle 35, and we get 3211,076, and that is newtons. Okay, and then the next question is asking us for the friction force. The friction force from our coefficient of friction times the normal reaction. Now, some questions they will not ask you these previous two questions. They'll just go and straight ahead ask you for the calculate the friction force. Then it means you do this separate. The coefficient of friction is given there. Okay, so in this case we already have our normal reaction, so we are taking that. We are multiplying our coefficient of friction 0.54 times our 3211,076. Then we get our answer 1733,981 newtons. Okay, so that will be as straightforward as that, nothing too complicated about it. More especially if they ask you questions like this, they break it down into questions like that. Then the next force, the next question says calculate the force required to move the object up the incline. So now when you're moving up the incline, if you choose to go up, your friction force, this one that we have solved for, 1733,981 is going downwards. The other force that is going downwards is your sliding force, your 2248,421. Both of these two forces are going in the downwards direction. So in order for you to go up, you need to overcome these two. So basically what we are saying is that, so for our force going up, what we are doing is force up is equals to your friction force plus your sliding force, which is equals to our 1733,981 plus our sliding force 2248,42, we add those two because we need to go up. It should be a force greater than that. After adding that, we are getting 3982,461 newtons, and that is how much force is required in order to move downwards. And well, we know the next force obviously will be minusing force going downwards. It is your friction force minus your sliding force. So this question is quite interesting. I want us to work this together and see what happens. What we have is 1733,981 minus our friction, our sliding force. So now when you look at this question, the friction force is less than the sliding force. So what the question is saying is that this object is already sliding downwards by itself. Remember what we said, the angle of rest, we have already exceeded the angle of rest. That's why the sliding force is already greater than the friction force. The friction force is less, and we will get a negative number, negative 514,499. Okay, and I like this question because most people would just say, let me remove the negative and say that is how much force we need. No, do not remove the negative, because in terms of force, forces are vectors. The arrow will either direct us whether it's the force going upwards or is the force going downwards. So in this case, that negative, you have to leave the answer as it is, or if you're going to remove that negative, it means you have to determine and say this 514,499 newtons, this force is not being applied in the downwards direction, but it is being applied in the opposite of the downwards direction. So what you're going to say is, if I remove the negative 514,499 newtons, but in the upwards direction, this is where I am going, then I can remove my negative sign. Okay, I hope it makes sense. That question I did deliberately so that we can get a negative answer. So most students, they panic, they get a negative answer, they were expecting something that would just give them a positive answer. But also, in this case, we'll look at the next question that follows, is that at which angle? So like I've already mentioned, this already clearly tells us that we have exceeded our angle of rest. The object is sliding downwards by itself by just us observing the sliding force being greater than the friction force. So already the object is sliding downwards. So when they ask the angle at which the object will start to move downwards, they're asking you for the angle of rest. Remember what I said, they will not ask you these questions directly, say calculate the angle of rest, but they will ask you indirectly. Like for this one, instead of just saying calculate the sliding force, they say the weight component parallel to the surface. For this one, instead of just saying the calculate the normal reaction, they mentioned to say calculate the component of the weight perpendicular to the surface. So those are some of the things that we will need to be aware of. So for the last question, which says calculate the angle at which the object will start to move downward by itself, that's the angle of rest. Now, angle of rest, we'll calculate it the same way we calculate for the angle of friction. Angle of friction, we said it is tan inverse the coefficient of friction. Same thing with the angle of rest at an incline. What we'll say is tan inverse our coefficient of friction 0.54. Okay, and then it will give us 28.369 degrees. Now this is an angle, not newtons, this is an angle. What basically this means is that at this angle 29, when the incline is at, not 29, sorry, 28, when the angle is at 28.369 degrees, when the incline is at that angle, the object will start to move downwards. Now notice that we are not at 28 degrees, we are already at 35, which means we have exceeded the angle of rest and the object is already moving downwards by itself. And at 35 degrees, you don't need to push the object downwards anymore because it is already moving downwards and it is accelerating. So in order for you to maintain a constant velocity, you don't need to apply this force in the downwards direction, but this will be a force in the opposite direction. The 514.499 newtons is, you should apply this in the upwards direction so that it moves, the object moves at a constant velocity at this angle. So the more we increase, the more force you need. We are actually slowing it down, or braking. It's a braking force. We are breaking it down so that it does not accelerate downwards, because we have already exceeded our angle of rest. Alright guys, with that you just need to practice a lot of questions. We'll do another video that talks about forces at a different angle, but still the object is at an incline, but the applied force is at an angle. Thank you for watching.